Okay, hi guys. I just wanted to do a quick example about finding coordinates, just in case it's been a while since you've seen it. Okay, so in this example, these two, B1 and B2, are bases of R3. So let me put that over here. They're both bases for R3. And in this example, I just want to find, like, I have x, y, z. I want to find the coordinates of x, y, z relative to B1 and also relative to B2. And let's see how. Well, it's not too bad. So we must solve some equations. You have to solve this one equation like this. Right? And we have to do this for real numbers a, b, and c. And then once we do that, we see that x, y, z will be a times the first vector, b times the second vector, plus c times the third vector. The coordinates of x, y, z will be a, b, and c. Okay. And this system of equations is kind of like, we'll treat it as a system of equations in 6 variables. So its coefficient matrix will be like this. Okay. Okay, and we have to row reduce this matrix. Notice that another way of saying this is that we're just we're finding the inverse of this matrix. Okay, so let's just go ahead and do that. Let me try it. Leave this up here. Right, so we have to row reduce. It's like almost row reduce for us, but let's replace row 3 with row 3 plus row 1. And what happens? Yeah, as long as I haven't made any mistakes, this is what we get. Okay, now let's continue row reducing. Let's do row 3 goes to row 3 minus row 2, and let's also get rid of this one. Let's do row 1 goes to row 1 minus row 2. What happens? So I get a new matrix. Okay, so I'll divide this by 2. What happens? And we just have one more step. Row 1 replace with row 1 minus row 3. That's the end. Right, so this minus this minus this. Okay. Okay, that's all fine. We've found the inverse of the matrix we started with. But now let's try and rewrite it in terms of the original equations we had. If we do that, we see that a is half x minus a half y minus a half z. See that b is y, and we see that c is a half x minus a half y plus a half z. Okay. So the coordinates, so if v is x, y, z, the coordinates of v relative to b1 are just a half x minus a half y minus a half z. Y is the second coordinate, and the third coordinate is a half x minus a half y plus a half z. Okay. So now we found the coordinates of v relative to b1. Now let's do the same thing. Let's find the coordinates of v relative to b2. It's going to be more of the same. So if you're fine with this, you can just skip. But let's just do the same thing over again. Let me remind you what b2 is. So v is just called, x, y, z. Some arbitrary vector in R3, and b2 is 1, 0, 0, negative 1, 1, 0, 1, negative 1, 1. Okay, that's b2. So we must solve a 1, 0, 0 plus b negative 1, 1, 0 plus c 1, negative 1, 1 equals x, y, z. And once we do that, the solution, like the values for a, b, and c, the solution, we'll put that into the coordinate vector for v. Okay. Okay, so how do we do that? Well, we just do the same thing again, except the matrix we start with will just be different now. So okay, and if you're not comfortable skipping ahead to this, well, just notice like this equation of vectors gives you three equations. The first equation is a minus b plus c equals x. The second equation is b minus c equals y, and the third equation is c equals z. And then when you write down the coefficient matrix of those equations, you get this, a minus b plus c equals x, b minus c equals y, c equals z, right? Okay, so now we have this matrix. Let's just blindly row reduce without thinking too much. And then at the end, we'll think about what it tells us, right? So we have row 2 goes to row 2 plus row 3. We'll do row 1 goes to row 1 minus row 3. Then we'll do row 1, place row 1 with row 1 plus row 2. Right, and as long as I haven't made any mistakes, now we can say that the solution to our original system is a equals x plus y, b equals y plus z, c equals z. Okay, so the coordinate vector of v relative to b2 is just x plus y, y plus z, z. Okay, and then we found the coordinates, the end. Okay, thank you for watching if you've made it this far. Bye.